Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. A formal good evening to you, grade 10s. I've greeted you informally already, but a formal one. Welcome to the session tonight. Okay, so picking up together, the last time we looked at the mole concept, of course, and just to recap on the mole quickly. Just a little short revision. We know the formula is the number of moles, which is N, is equal to the mass of the substance divided by the molar mass of the substance, okay? And if we take a little short example, okay? This example is a random example from not asking one thing specifically, but what happens if I have the number of moles equaling to about 0.67 mole. Remember, that's what it's measured in, MOL. And the substance is about sulfuric acid. So sulfuric acid is H2SO4. Okay, so you need to find the molar mass of H2SO4. So I've got 2 times by 1 for hydrogen, plus sulfur I think is 32. Let me just go grab a periodic table. Let's see if I'm right. Yeah, it's about 32. I'm going to use the whole number, so plus 32. And then plus 16 times 4. Okay, if we put that in on our calculator, which I have to because at this time of the evening, yeah, my brain is not as fresh as what it was at 3 o'clock this morning. Because 3 o'clock in the morning, that's when my brain is most fresh. Okay, so we've got 2 plus 32 plus 16 times 4. That gives us to a molar mass there for sulfuric acid to be 98 grams per mole. Okay. Sulfuric acid. Okay, cool. So now if we want to find the number or the mass of sulfuric acid, okay, we use the same formula. Let's pick a different color maybe. N is equal to small m over big M. So I got 0.67 here is equal to the unknown mass all over 98. Okay, so obviously mass is going to equal 0.67 multiplied by 98, and therefore the mass in grams, 0.67 multiplied by 98, will be about 65.66 grams. Now I'm going to move over into something that's called percentage composition. Okay, now we're going to take our formula a little bit more to the extreme. Okay, all right. Percentage composition. Okay, this is quite fun once you get the hang of it. Okay, so let's just put a head in here so we know what we're doing. All right. So we got our percentage composition right there. Okay.
JP?
Which is the, yes, talk to me. What's going on? Am I being
If I remember correct, from what I did in class, is percentage composition like, so like they give you like the amount of like mass, so be like 200 grams of this substance or whatever, you have to work out like how much of that's going to be like hydrogen or whatever. If I remember, I don't know. I can't explain anything today.
No, you actually explained that pretty fine. Yeah, that's exactly what percentage composition is. Well, how much percent of this molecule is this atom? So you're right.
Yes.
That's right. Yeah, that's exactly what percentage composition is. Okay. In a more probably scientific way, or explanation maybe just for the, all the boys watching. Percentage composition of a compound is a relative measure. My gosh, my handwriting is actually a bit better today. Measure of, again, that word you use there, the mass of each different element. Different element present in the compound. So I'm just going to stop the definition here at present, which is present in the compound. All right, cool. Got that. Now, if we take a look, for example, let's have a look at an example of water. H2NO. Okay, water shows the percentage of the mass of a water molecule, which is made of about hydrogen. Okay, so hydrogen, let's say, for example, is 11%. Okay, and the percentage of the mass of oxygen is about 89%. Which you may think to be a little bit absurd because there's double the hydrogen in only, one oxygen. But the molar mass of oxygen is obviously quite large. Okay. So how do we calculate percentage composition? All right. To calculate it, we follow the steps. We first, number one, if I can just scroll down a bit. The first step is to find the molar mass of the compound. First find what is the molar mass of the entire compound. So we add in each atomic molar mass of each element up to find what is the molar mass of the compound. Then number two, we calculate the percentage mass of each element by dividing, the molar mass of the element by the total molar mass of the compound. Okay, so we divide the molar mass, that's what these quotation marks, the same thing that's there down here, of each element by the compound's molar mass. Okay, to obviously get, and then obviously once we've divided it, we times by 100 to get it what it is in percent, or in percentage. Okay, that's the steps. Make sense? Everybody fine? Everybody comfortable? Ladies?
Yes.
Yeah.
Cool. Now, if we take a little example that we used earlier on, let's take H2SO4. Okay, so we know the molar mass is equal to 98 grams per mole. We don't even need to calculate it again. Okay, that's what it's equal to. Okay, so now that we got all of that, we know the three atoms that make up H2SO4 is obviously H, S, and O. Okay, so we find that the molar mass, of course, of hydrogen here, we have molar masses 1 each. Okay, so together would be 2. Sulfur 32. And oxygen we have 4 16s. Okay, so altogether this comes to about 64. Altogether this comes to 2. Okay, sweet. Now, of course, if we want to take our percentage composition, so we have a look at your percentage. Okay, for hydrogen, we have 2 divided by 98 multiplied by 100, which will give you about 2.04%. Then for sulfur, of course, you have 32 divided by 98, okay, times 100. And that will give you about 32.65%. And then we have the last one, oxygen, which we now have 4, and they're all valued at 16 each. So that's 64 in total, divided by 98, multiplied by 100. And that'll give you 65.31%. So if we want to check if our percentage composition is obviously correct, what do? We obviously go and we add up all of these bad boys. So let's add it up quickly. 2.04 plus 32.65 plus 65.31. It all adds up to 100%. I'd show you, but you can't see me. Okay, it's 100% on the calculator. So obviously 100% means it's complete. It's 1 out of 1 is 100%, so that means, okay, cool, everything's working perfectly. Okay, there's nothing missing, etc., etc. Okay, sweet. Alright, great things. What I'm going to factor into my session tonight, okay, for this recording as well, is going to be some revision of vectors and scalars. Okay, just some revision because a particular student, whose name I shall not mention, of course, has been doing this at his school, and of course, teacher's a little bit absent from the class, so I've already done it with everybody that has seen my previous recording. So we'll just do some revision on it because, of course, if we haven't passed the final year exam yet, then we can't say that we know it really. Okay, so let's go over it together. Now, first question, of course, this is just revision, so we're not going to go too much into the detail of it as if we're learning it maybe for the first time, but we'll just revise it and obviously mentioned, of course, the main points, okay, of it. Okay. I do need to make sure I got my textbook with me so that I don't speak, obviously, gibberish to you. But what I will say to start the revision is that we have two groups. Okay, we got vectors, and then we got, obviously, scalars, which I'll use in a different color so we can distinguish between the two. Okay, now, scalars is very easy. The definition of it is a little bit easy, or easier. Okay, so scalars is, first of all, it's a physical quantity. Okay, quantity, physical, that, and I'm paraphrasing a little bit here, has magnitude. Magnitude means size only. Okay, an example, and I'll double check my textbook to make sure I have the right example. Mass, speed, distance. Okay, they only have size, magnitude. So mass, currently as of Saturday when I weighed myself, 101 kilograms. Okay. Speed, meters per second. Distance, meters. Okay, that's it. Okay, it's a physical quantity that has magnitude only. We have vector, okay, it's the same thing. It's also a physical quantity. Okay, but the physical quantity that has magnitude and direction. So the cousins of these three, example, weight, mass times gravity, okay, or weight, or otherwise known as, also forms part of force. Opposite of speed is velocity. Velocity is speed, but it is speed in a certain direction. Distance, displacement, describing the movement of a particular object or thing. Okay. Now, vectors do house a couple of properties before we learn how to draw them. Okay. The first property, and I'll mention it first before I write it, is that two vectors are equal if they have the same magnitude and same direction. Now, to bring in drawing vectors, okay, because there's two methods of them, but let me just mention this quickly. So, graphically, of course, they'll have the same length and they'll be parallel to each other, okay, which is obviously something we should remember from doing mathematics, okay, under geometry. Okay, so how do we represent a vector when we draw it? We obviously draw it by an arrow, and obviously a arrow, or a body of an arrow, or the length of an arrow. So the length of an arrow when you're drawing a vector would represent the magnitude or the size of the vector, the value. Okay, and obviously we'd have a scale. So obviously we draw on a page with ruler. We obviously rule obviously in centimeters, right? So 1 centimeter might equal 10 meters. Or something like that, or maybe 5 meters, or 1 centimeter might equal 1 meter, okay, depending on the size. Probably wouldn't equal 1 meter, you probably have to make it a little bit more, but 1 centimeter equals 10 meters, that's pretty much okay. You obviously would draw it with an arrow, so an arrowhead, like this, okay, or some people just like to go for the big, like that. It's fine. As long as you have an arrowhead on it, it's fine. Okay. Positive vectors point in the positive direction and negative vectors will point in the negative direction. So usually from, if I draw the compass directions, on like a Cartesian plane like drawing, we got north, we got south, we got east, and we got west. If I can fit west in there, there we go. So we usually have negative for west, and we usually have positive for east. So if we change this arrowhead around a little bit here, of course, we'd obviously have a positive here, and we'd have obviously a negative vector if the arrowhead was drawn like this, because the arrowhead does dictate direction. And since I've used that arrowhead, I should probably make it the same for this one. Okay, so we got the negative direction here, going obviously the westerly direction, and we've got the positive direction here going to the right or forward. Okay, direction. Okay. How do we add vectors? Okay, so this is the second property also mentioned here. 3, how do we add vectors? Now, we can do adding vectors, of course, by adding them in a straight line using sign conventions. So obviously the right would be a positive. If you go to the right, then that will be positive. And if you're going to obviously the left, it will obviously be negative. Okay, so let me just add a negative sign there. So instead of 1 plus 2, so we'd have like a straight line sum. So if it were 10 plus minus 4, your vector sum would eventually equal 10 minus 4, which would end up being 6. Okay. We add also vectors using graphical methods. Okay, so although I've displayed how you draw a vector, there are 2 types of ways to actually go ahead and draw a vector, usually displacement of a certain object, using 2 types of graphical methods. One being your head to tail method, the other one being tail to tail method. I'll take time to revise this because this always confused me when I was a high school student as well, all the way through, except matric. In matric, I finally nailed it. I only really nailed physics after two years. Okay, of doing absolutely horrendous at most of my tests. I remember, short story quickly, because story time is good time. I wrote so at the school, Weinberg Boys High that I was, the physics department though, you would, if you didn't reach your goal, so in other words, they would have a section for your goal that you think you're going to achieve on the paper, what you want to walk away from at the end of the exam or at the end of the test. And if you got your mark and your mark was less than your goal, so let's say you wanted 60% and you got 58% if the test was out of 50. So you got 29, you didn't get 30. You'd have to rewrite that test. You'd have to, be compulsory. And I think one time I took a test 3 or 4 times until I finally reached my goal. And every time I lowered my goal all the time. But eventually I surpassed it. So this type of stuff really also confused me. But that, I think I was in grade 11 at the time. In grade 12, I never took any rewrites. Because finally things clicked. Anyway.
Maybe.
Yeah.
Quick question.
Sure.
What if your goal was 80% and you got like 79%?
So 79%, well, you'd have to get a half a mark if it a test out of 50. I mean, because most tests were out of 50, because you only had an hour to write it. Yeah. So if you got like 78%, so that's about 39 instead of 40. Yeah. You must rewrite until you get your 40.
Oh my gosh.
Yep. But every time they rewrite, they change a couple of questions in the test. They change the numbers a little bit and stuff like that. It was good. It made people work harder and actually improve their academic pillars. So it wasn't all that bad. I mean, it made a better physics student out of me at the end of the day. I tutor the stuff now, so not too bad, I say. First method, of course, back to the revision, is called head to tail. Head to tail. Okay. This has you'll see once I draw it now, you'll see why it's called head to tail. Okay. So let's say the arrow, where the arrow is, that's the head of the vector, and of course where the line is, of course, the body, and at the end of it, where there's no arrowhead, that would obviously be the tail of the vector itself. Okay. So let's say we've got two movements. Let's say we got A going this way. We draw it in a different color. A, arrow on top showing it's going in a certain direction and it is a vector. And then B goes here. B. Now notice where my arrowhead is and where my tail of my second arrow is. Okay, I extended my line a little bit further down here and I shouldn't have, I apologize. Okay. I start drawing the tail of my next arrow, which is my other vector, at the beginning of the head of the first one. So my head of the first is touching the tail of the second, okay? And then the resultant would obviously be this entire thing over here. Okay, this would be, oh, I need to extend the line there. Let me undo that. Okay. And this would obviously now be the resultant vector of A plus B. Okay, the resultant. Okay, but because of this key little thing here, the head of A is touching the tail of B. So head's the head, the name head to tail, the head to the tail. Then we also have the tail to tail method, which I never really liked. But in some papers, they asked you to use a specific method. So when they didn't ask, JP always went to the head-to-tail method. But when they asked for tail-to-tail, of course, first I'd throw a bit of a tantrum in my mind, and then I'd have to go ahead and just do it. Okay. However, because at the time of grade 10, I was a bit foolish, and I thought I could outsmart my own examiners, I obviously had to sickle and think about how the heck I had to draw it. But it's actually pretty easy. So, let's also get another color for this one. Let's do this one. So let's say I've got A going the same direction here. Okay. Now I need to draw my tail from the same position. I can't draw the tail here because then it's a head to tail. So I must draw the same direction, but I must draw it here. On this side. B. The tails of the arrows are touching each other. Then the resultant, of course, would be this one. See, the lines match, just drawn differently. Right, that's the tail to tail. Okay. Tail to tail method, head to tail method. Choose one to learn a bit better than the other. Okay, I always like the head to tail because it's a bit simpler and also makes the most sense. All right, just makes the most sense for me. But anyway, I'm different to everybody. Be different. Be you. Be uniquely you and unapologetically you. Anyway, this is not a live class, etc., etc. Just to explain the resultant vector. A resultant vector means the key word there is result. So as a result of the two vectors, we have a resultant vector that is formed, which means it's a single vector that has the same effect as the two vectors or other two vectors or other vectors combined. Okay, that's the same effect. Okay. So I got a question here. Got a question. The question here that I've drawn a compass direction here, and I've got a vector going in a certain direction, which has been unspecified. Okay, well, we can obviously see because of where it's in between north and east. Sorry, but my question is, which option, or obviously there's more than one option here to say this. What is the correct direction of vector A? All right. How would you describe the direction of this vector A? Can anybody tell me the answer?
Would it be east 45 degrees north?
Oh, okay. I see where you're going with that. That's an option. Okay, anybody else before I but maybe declare if Rhesus was right or wrong? Anybody got another suitable answer there? Would like to take a stab? Trying to look at the question there. Not definitely this one. Yeah. Okay. Cool. So it's in the okay. So let's go about deciphering this question. Okay. So it's in the middle of north and east, right? But it can be looked like a different way. Okay. So Reese, your answer was east 45 degrees north. That was Reese's answer. Okay. Your answer is not 100% correct, but it's also not 100% wrong either, because you've mentioned the right things, possibly just not stated correctly. So there's multiple ways, like I said, to describe this. One, we can say that what's in the middle of north and east? What is a compass direction in the middle of north and east? Who knows?
Northeast.
Good. Northeast. So an option is just to say, well, it's northeast. That's an option, okay, which is correct. Another option, combining Reese's answer, because Reese actually shared two answers there. Well, this vector is 45 degrees east of north. Can I fit north in here? Another option would be to say, well, vector, if this is 45 degrees here, it's also 45 degrees on the other side, so it can also be looked at as 45 degrees north of east. Okay, which obviously backs up this answer, northeast, east of north. Both correlate to the first one as well. You just put the degrees in there. Okay. Another also suitable answer would be to say on a bearing of 45 degrees. Okay, and another option which is also good is 45 degrees from the east axis. This is the least likely answer to give, though. Your top three answers is what you really want to have a look at. And even more than just the top three, this two over here. Possibly this one as well. Whenever you get asked a question like that. Right. Okay. So these join of vectors, of course, they come into to play. There's lots of activities in your textbooks that exist with join vectors, etc., etc. But most of it is referred to and more as and asked at an exam level under motion in one dimension. Okay, which I will aim to revise the next time we see each other. Okay, but I'm gonna just go revise scalars and vectors for this session from mechanics. Okay, and then we're just gonna park it off there for a while. Thank you, grade 10s, for joining me tonight, looking at percentage composition, as well as revising a little bit of mechanics, as well as somebody in the class has just started mechanics, so we'll be revising a little bit for the next coming weeks and just touching on that little topic a little bit, just to remind ourselves, as again, that topic will come back in term 4 when we do final exam. So if we get a little bit of a head start in revision, awesome. Okay, please don't forget to like this video and comment, as well as subscribe to our channel for more video content.